Hello and welcome to Dinis Guarda YouTube podcast show. Once again, profiling global thought leaders and visionaries, and as well portraying the way we deal with the biggest challenges of humanity, technology, and business. One of the things that I've been always excited is to look how we can actually create value, innovation, and especially keep doing it on a continuous way that is sustainable. And my special guest for today is one of the personalities that actually has been working on that all his career, but as well represents one of the biggest brands in the planet that has been actually working for over 177 years old. That's Siemens. And my special guest today is Dr. Micahel May. So talking about Dr. Micahel May is quite impressive because his career is very impressive in a lot of different areas. So Dr. Micahel May is a technologist and researcher, especially in the areas of AI, data analytics, machine learning, and big data architectures. And he's heading the company core technology, data analytics and AI at Siemens. In Siemens Corporate Technology, Munich, he is responsible for 14 research groups in Europe, US, and Asia. Before joining Siemens in 2013, Micahel was head of knowledge discovery department at Fraunhofer Institute for Intelligent Analysis and Information Systems in Bonn, in Germany. And his work has been amazing in the areas of Europe-wide data mining research networks, funded by the European Commission, just an example, but he's as well working in a lot of areas of research around data, technology, AI. Dr. Micahel May holds a PhD in machine discovery of causal relationships from the graduate program of cognitive science at the University of Hamburg. And this interview is in the area and as well powered by the AI for Purpose Summit 2024 in Munich, Germany, where we are here. Dr. Micahel May, it's a pleasure to have you here. And you have actually an amazing wealth of experience that goes through so much complex areas. And of course, it represents one of the biggest companies in the world that actually, what is impressive about Siemens is the continuous innovation. So before we go there, I want to start by you. So as someone that has been building a career between industry, academia, and as well putting together research, business, and technology, how that part starts in your career? What made you be the person you are? It's something normally starts with education, family. I'd like to touch a bit on your basis to make who you are today.
Very early, I got fascinated how learning works, how scientific discovery works, and how could I make that work in a computer, for example. So that was a very early interest I had. And then back in the 90s, so this is when I started to get interested in AI, and at that point it was still a big niche topic. So I mean, I thought at that time there was a hype on AI, but looking back, it wasn't. It was a research topic, and the world didn't care too much at that time. But I was interested in that, and I wanted to find out how that works, learning, how does it work that I can program a computer that learns. And then I got the opportunity in this, what you mentioned, this graduate program in cognitive science at the University of Hamburg. It was a very interdisciplinary place, and one of the few places at that time where you really could do AI and early machine learning. And my PhD in this graduate program. And at that time, it was research, and it was far away from the real world. But then a little bit later, so mid-90s, this topic of data mining, how it was called at that time, started. And that became much more practical. It was still the same thing, so machine learning, but suddenly there was data there where you could apply it to real problems, not very deep scientific problems, but problems of how a machine would work, or even problems like marketing and so on. And then I, after finishing my PhD, I started at Fraunhofer at that time in the topic of data mining. so which was a kind of applied machine learning, I would say, and tackling the things which were feasible then. And this is something I enjoyed a lot compared to the university. That on the one side, you work in a academic environment, you do some research, but then there is a customer, there's somebody out there who cares what you're doing. So it doesn't, it's not irrelevant if you solve a problem or don't solve a problem, but somebody wants to know, somebody even pays you for that, and you have to deliver something. And I always enjoyed that a lot. If there's somebody who cares what I'm doing, and and then so I worked at Fraunhofer, starting some, as you mentioned, networks of excellence in the European community, which were projects funded by the European Commission. One of them was a network with about 120 universities, where professors from the university, researchers from the universities were in, and we jointly tried to shape the way data mining and machine learning was done, and that I did for many years. More and more industrial applications in telecommunication, in marketing, and in many different areas. Also organizing an international conference on machine learning is now one of the biggest conferences in the field. 2005, we had it in Bonn, and I was acting as the local chair on that conference. And and then things developed even more. And then back in 2012, the German Ministry for Economics, they asked about big data. So is it a big trend? Will it change the industry or not? And at Fraunhofer, we did a study for them and found out, of course, yes, it will change the world. And then a little bit later, Siemens asked if I would be interested to join Siemens, and that's what I did back then. And since 11 years now, I'm at Siemens and try to shape the way we do machine learning, data mining, and AI. And what's very, very nice to see is that the early things which were in research in the 90s, they now all come back and become reality, and even on a much larger scale than we imagined back then. And that's very nice to see, and very nice to be part of that story that now really starts to change the world at large.
Oh, it's impressive, and like you said, your trajectory from pure academic to industry and all the innovation that this implies. And before I go to Siemens and the work you're doing, I want to touch one thing that I think is unique, because Germany, I think, is probably one of the few countries in the world that has a strong relationship between innovation, academia, and industry, and as well continuation. I see that, for instance, if I come to this conference, a huge percentage of the keynote speakers are doctors, where if I go in conferences around the world, this doesn't happen. So how did this role of, for instance, your experience on the Fraunhofer Institute and then in Siemens and your approach to innovation and research, because you kept this continuous work, and I think that's part of the success of Siemens. So can you touch a bit that?
I think in a field such as machine learning, it's indeed very important that you can move from one side to the other. If you are just on the theoretical side, then probably you miss the real world impact. If you're just on the applied side, then you miss a lot of innovation which comes every year. So it's good to be in both places. And as I said, so I always enjoy to make the transition from the one side to the other, and then back. And Fraunhofer is a research institution that is really built around this idea of transition from research to practice and back. And I would say Siemens Technology, where I'm working, so the pre-development, innovation, research department of Siemens, it's quite the same. So you need both. You need the contact to the university, and then on the other hand, you need really to sit down with our business units and discuss what would help you in the real world. So what is not a theoretical problem, but what would help you in the real world. And there I always felt Fraunhofer was a good training for Siemens in a way.
Oh, it's really impressive. So Siemens is one of the powerhouse technology companies in the world. I think in terms of number of patents is the biggest in Europe, and I think one of the biggest in the world. And as we speak, I think you pass 1,400 patents just in AI. But altogether, I think it's over 150,000 patents, something like that. And you manage one thing that is quite impressive, you in your position as a global leader, you manage research groups across Europe, US, Asia, and I think even Latin America. So tell us a bit, first of all, about Siemens, where it stands and all this innovation, because it's quite impressive in a world that is mostly US and China. But Germany keeps that powerhouse for 177 years. So for people that don't know so much about this innovation, the first part of the question is a bit about this innovation, and the continuation of focus on patents, focus on research. And the second part, how you manage all this collaboration across completely different geographic locations that goes to completely different countries, different cultures, and different teams.
The first part, innovation, has been important for Siemens since it has been built. So patents was always a big topic for Siemens, and is the basis for being successful in technology. So this is really in the DNA of Siemens to do that. And for that reason, we're driving that forward, profiting from this close interaction with academia and then our business units on the other side. So your question, how to manage the international teams. This is maybe one of the most interesting part actually of my job, since you get exposed to many different cultures. People, every country does it a little bit differently in terms of innovation. On the other side, you quickly find out in the computer science or AI field, then there's always a lot of commonality. So it's maybe what brings you together in AI is much more than what is separating you in terms of country. And we feel we need to be at all the places where our customers are. So we need to be close to the customers. So this is why we need to be in the US, in China, in India, and in Europe. And Latin America, by the way, not at least not now. So we need to be close to the customer and need to understand what their problems in the regions are. And also, of course, AI is a field where it's difficult to get the talent. And so if you are in many regions, then you have more possibilities in the various regions to get the talent. And I mean, how we drive that. So make joint plans, of course, who is working on what part of the big AI topics. So there's not just machine learning, there are the more logic-based things. And so every group in every country has their own speciality. But all of them, they also have a big common denominator on which they work, which is the general AI stuff, data analytics. Some machine learning is done by all the groups I have. And then it depends a little bit on the customer, what the customer really needs in their country.
Yeah, that's quite impressive, because we're talking about a lot of different cultures, a lot of different backgrounds. So that brings me to, Siemens is a big player in a lot of different areas of tech, especially industrial manufacturing, and a lot of areas. And now increasingly is becoming a global powerhouse in AI, especially in the areas of industrial grade AI or industrial AI. So before we deep dive in the work of Siemens, I think it's important to separate the notion of AI and generative AI and all these different areas and the notion of industrial AI, which I know that Siemens is one of the biggest proponents of that. Yeah. So could you define it as an academic? I think you can teach our audience a lot about that as well.
Yeah. First of all, it's important to understand what is Siemens doing. So Siemens is increasingly a technology company, but Siemens is a company that builds trains. It's a company that builds automation equipment for the factory. It's a company that builds energy system or contributes to energy system in many ways, that equips buildings with technology. So this is still the space in which Siemens operates, and this is what we call the industrial space. So in a broad sense, what we mean by industrial, but this is our playing field. And now the task we have at Siemens is taking the AI, which is there, which has great promise in many areas and can be applied in very many different areas, and to make it useful for the industrial space in which we are working. So like building AI for an automation system in a factory, or building AI to make trains more autonomous, and so on. And doing that properly, so for the industrial space, using artificial intelligence, and doing that properly is what we call industrial AI. And what does making it properly mean? Many things. So customers of Siemens, they expect that if we deliver a product, that this really works in the real world, that it doesn't have failure, that it's safe to use, and all that. And the requirements that we have there are much more stringent than they are maybe in the consumer space. So making products which are safe under industrial standards, this is what we call industrial AI. This then also has to do with getting products that get certified by the authorities. If you build a train, for example, and that then has much more requirements than many other areas.
I want to touch that because that is a very sensitive area that, so like you mentioned, you're doing with trains that take thousands of people, planes that go in the sky. And I heard somewhere, and I don't know all the details technical, but I would say from most of the cars that are produced in the world, I think Siemens is a huge component in almost all the cars in the planet. So how do you manage all of these legacy systems in one end, and then all this innovation of AI, and as well how you manage to put this industrial AI new concept? I think it's a key concept that is not very well taken mainstream, but it's increasingly more important for universities, for companies, to actually make AI more useful, but as well more adapted to the conditions in society that you have. I would like to see how you adapt and you manage all these different areas together.
It's a great question. I mean, it helps now that AI is such a big hype, of course. So, I mean, years ago, I thought it was a hype. It's a big topic, but the world maybe thought otherwise. Many customers thought otherwise. But I think now it's very hard to find somebody who does not think he should worry about AI, what he can do with that, or start a project with that. So there's a big momentum behind that, what helps us a lot. And then it's also clear in terms of use cases. Some applications are quite easy to explain, like you have equipment in your factory, in your energy system, for example, and you want to see will it still work till tomorrow, or will it fail? So this is called predictive maintenance, and that's not hard to explain why this is potentially useful. And so nowadays we increasingly have the AI tools to address these problems better and better. For example, vision for visual quality inspection, time series analysis for seeing if some piece of equipment has some bad vibration and might fail tomorrow. So there a lot of has happened over the last years, and now we get the next big boost with the large language models, which allow on the one side the users really to talk to the machine, to ask questions in natural language and not in a very specific programming language, and also to get advice, which is often really useful on how to program such a system, or on troubleshooting, and so use cases are now everywhere, and everybody recognizes that this is it.
Yeah, you make it sound so easy, but this is quite complex, and this shows as well the fantastic work, but as well the challenging work you guys are doing every day, because of course it affects thousands of people, if not millions, and it has a lot of consequences. And as well, there's a lot of hype around, of course, especially all the generative AI, large language models, and we talk about all these big players in Silicon Valley. But what I'm very excited, and especially Europe has been a leader on this, is a discussion that is, especially there's a sense of governance around data, a sense of ethics, but as well a sense of that maybe you don't need a large language model to manage a factory or to manage even an entire, entire government or something like that. So can you tell us specifically, bear in mind that at the moment we have a couple of prevalent generative model systems that mostly are all dependent on more or less the same foundations. And you've been doing this for decades, so you've been researching this from the research of machine learning into the large language model that made possible what we have right now. So how do your teams and Siemens work in managing that? For instance, if you use AI for a factory or AI for mobility or for one of these big projects you're doing, that you can manage both an LLM or a medium-sized language model, and you can actually adapt it towards the needs. Because, of course, most of the studies say that, especially with OpenAI, around 20% of the systems are still with hallucinations. So there's a lot of work to clean that and create the trust.
Yeah.
So I would like to hear your opinion.
Yeah, it's great that you mentioned that. I mean, hallucination, of course, is maybe the number one problem we have to solve to make AI industry grade, or generative AI industry grade. And hallucination means that the machine can come up with what it thinks are facts, but which in fact are hallucinations. So it dreams or it hallucinates. And this, of course, in a safety critical environment can be a big problem. So how do we deal with that? I mean, for quite a while, I'm stressing the point that AI is not just generative AI, is not just machine learning, is not just deep learning, but has very many facets. So there's the one which is more what is called inductive, or probabilistic, which is based on inference, which might sometimes be wrong. And then for decades, there is research on other parts of AI, which is more logic-based. So, and that can give you guarantees on correctness. And for many applications, it's good if you combine the one side of things, so the probabilistic part, and then the more logic-based part that can give you these guarantees. And one very practical way we do that is to bring in the domain knowledge, of which Siemens and industrial companies have a lot, which we structure in the form what is called knowledge graph. Knowledge graph is a formalism where you can model terminology, knowledge, so ontologies, for example, and where you can also structure fact-based knowledge in a way that if your representation is correct, then all the inferences you make from that are also correct, because it's based on logic and not so much on probabilistic inference. And now the thinking is, if you combine these two things, so domain knowledge captured in a way that a machine can understand it and can reason about that, and then the large language models and the more learning-based parts, then you can, on the one side, still give guarantees on that what you do is based on facts and does not hallucinate. And on the one side, get the advantages in generating ideas, generating hypotheses, which language models give you. So I think it's like you make inferences, which might be a bit risky at times. So that would be the probabilistic part. But then on the other side, you have learned a lot of facts at university, which are hard facts, which you bring in, which make sure that your inference is not incorrect. And so bridging the two worlds is what I think is very promising. So domain knowledge on the one side, if possible, based on hard facts like knowledge graphs, but also other mechanisms are possible, and then the more probabilistic things.
Oh, that's a masterclass. So thank you so much, because the way you explain it, that this is for people listening to us, is a critical element, because I think AI right now is everything in the same box. And everyone thinks about ChatGPT or all these different things, but there's much more. And of course, when it comes to industrial grade AI, which is partly what Siemens is doing, is super important. So as Siemens is one of the biggest tech players and of course industrial players in the world, there's a huge component of legacy systems. So you deal with in some cases, and of course I always like to bring a story that I love about Siemens, is that Siemens started doing telegraph innovation in the beginning, and telegraph was one of the first things that created the fourth industrial revolution. So this was over 170 years ago. So with this work on innovation, but as well dealing with legacy systems, what are the things for people listening to us that are panic with AI? And I think even me, I panic sometimes, because there's a lot of disruption, and the capacity of a lot of these systems is, I'm sure even for you, that you've been building them is scary. But especially, I'm particularly interested to see the work you've been doing to keep the stability and as well the trust, because one of the things you are focused is trust, security, and as well the sense of creating, I would say, a transparency around the work that is done. So how do you deal with that? Bear in mind the complexity, the governments you work, the big corporations, and as well the sense of risk and the sense of continuous, because you have to keep the business going.
There is not a single answer. Part of the answer I might have already given. So if you take parts of AI which are easier for humans to digest, like a rule-based system, and there we come back to the knowledge graph and this more logic-based things, then they are able to explain better what the models are like. So explainable AI is a big topic these days, and you can use that to increasing the trust in the conclusion which the AI is doing. Then another pretty conventional thing maybe is that you closely work with the domain experts and provide one layer of security or safety around the AI you're building. So you build AI, you use things like reinforcement learning, which is a quite advanced methodology, which, for example, we have been using for years with our colleagues from Siemens Energy to control the working of the gas turbine, so the control policy of the gas turbine. But then you work with the engineers from the domain and build some kind of virtual safety net around that makes sure that nothing can happen, and which is understandable for the domain experts. And that takes a lot of efforts and interdisciplinary teams to make that work. And this is sometimes in an academic environment totally underestimated. So you think you build an algorithm, and once you've built the algorithm, then the thing should work. But sometimes it's a couple of years, maybe even, that you have to work on it, making a good idea which works in principle to really make it work in practice so that it's safe to use. And there, I think, is an advantage the industrial companies maybe have in that area, because they're used to doing that, used to build products which are safe. This is a partial answer to it.
No, it's a very good one. And I think it's quite still complex, but it's super critical. So one of the things that I know that Siemens has been working is global standards and regulatory bodies, and all the areas around bringing AI governance and ethics. So from your experience working like in projects from the European Union to that have a lot of multiple countries and as well big industry, great projects, what would be the a kind of a summary how you see the AI governance from perspective of Europe, but as well you have a global footprint, and what would be that you suggest?
The AI regulation is a topic you must deal with if you want or not. So you will not be able in a short period from now to deliver products to customers which do not somehow give an answer to how do I make it safe, how do I make it responsible, how do I meet the privacy requirements attached to that. So you have to deal with that. And it's also clear with the complexity, with the chances, but sometimes with the risk of AI, that you need some level of governance that you have to address. And so you need to have answers. Why is your system secure? And Siemens, for a couple of years now, is working on that, preparing for regulation, but also trying to seize the opportunities which that gives you, building systems which are, as I said already, industry grade. If they're industry grade, then by our definition, they will also comply with the upcoming regulations. So I think it's a factor you have to deal with. It's also a factor which can make you more attractive for your customers. If they know what you're building is safe, it does comply with all the regulations, then they might be inclined to buy your products or use your products with more confidence. On the other side, of course, we have to see we need some level of regulation, but also absolutely we must not overdo it. So if there's too much of it, then it can become a burden for innovation. It can make the process much more lengthy, more expensive, and then there's a risk in actually doing this kind of over-regulation. And I think the jury is still out on which side we will land in different countries. But this is something we need to be absolutely clear about. We need to have regulation which is good for innovation still, and on the other side keeps things trustworthy. And I would say, even if there would not be regulation, I mean, Siemens would always build things or aim to build things which are safe and trustworthy, even without external regulation. But but this is a bit of a trade-off between.
So I think for our audience and for people listening to us, I would like can you just describe some of the AI products and some of the major products that you are managing as we speak?
Mm-hmm.
A couple of them I know that people can find in the websites, but I know that you guys have a lot of different solutions. I would like just to touch that, and probably if you pick one and how, for instance, that model can work for people listening to us. Because I think sometimes when we talk about these things, people get lost, and I always try to see, starting with example.
Yeah, maybe I start with a recent example, with a recent product that Siemens has been bringing out. So Siemens is selling simulation software, for example, for the automotive industry or for the oil and gas industry, and you use simulation to build better products. So the next car, which is more energy efficient, and before you build it, you do a lot of simulation to make sure that what you build is in fact what you wanted to build. And these simulation systems, they are costly in terms of computation time. So you need a lot of computation, many hours, many days, many weeks in cases until you have the results, because there's very complex mathematics behind that is used for the simulation. And that takes time, that costs energy. And maybe because it takes so much time, you cannot explore all the options that you have in the simulation. So that's the state of the art. Now the question is, wouldn't it be maybe better if we can speed up the whole process? For example, by making it faster, then it consumes less energy because it doesn't compute that much. Maybe it even finds solution that could not be found before. And so in the end, you get a product, maybe more environmental friendly product. And this is what we have been doing. So Siemens is now selling a product using AI, which uses the AI to predict when is a simulation, are you think good? No? Bad. When is a simulation bad? So it tries to predict what are the parts in the whole design space which you need not look at, because you don't get a good result anyhow. And using these techniques, you can filter away many of the potential solutions that have to be calculated, and then you focus just on the promising one. Maybe this is how we humans are good at thinking. So we don't evaluate millions of possibilities, but just a few one. But we know where to look, where to focus on the right part, and there the AI helps us to focus on the right part. So doing just those simulation which are promising. This we have developed with our colleagues and colleagues from Siemens Energy, for example, using that, saving thousands of hours of compute time. So it's more environment friendly. I mean, people always say, yeah, AI consumes a lot of energy. It's in that sense, it's not good for the environment. But that need not be the case. There's also forms of AI which save a lot of energy and then bring results, in that case, even results that have a more longer time you can use that. So it saves spare parts in that case and allows operation, which is also more environment friendly. So in 3 dimension here, it's good actually for the environment. And that's a product I think we're quite proud of. And then there are many others. So, I mean, doing predictive maintenance for trains, doing predictive maintenance in the factory, and at the Hannover Fair, Siemens has recently announced the Industrial Copilot, which helps you to provide code for automation equipment and much more. But always fit to the Siemens industrial world.
And I like the focus. It's very important, and I think that's one of the critical areas. So you touch sustainability. So at the moment, there are some studies that say that, for instance, the consumption of ChatGPT-4 and OpenAI is equivalent to a country like Belgium. And there's more and more questions around the consumption. You said as well that can be managed better. So from your experience with these models and as well working with big industrial elements, and of course Germany as worldwide, I think is one of the countries that has better tradition in terms of green energy, sustainability and energy consumption. So tell us a bit about, especially in the case of AI, how can we look at sustainable AI, but as well solve a lot of the problems around computing and supercomputing.
One example I just gave is this saving energy. But for the topics of the large language models or more general foundation models, we often say large language models, but there are different kinds for vision, for time series, for geometries, so there are different kinds. But they're a very important and active area of research is to make these models smaller. Some people call it a small large language models or small language models. And this is a very important area of research, so coming up with the same level of sophistication or quality of the model, with being much, much smaller in the number of parameters, which directly translates into the energy consumption. And there, over the last 18 months, I mean, we have seen a lot of progress with some of the open source models and the Llama family, for example, which have good results while being drastically smaller. And then there's a lot of research to be done, maybe for some particular domain, just maybe like an industrial domain. So if you don't want to have a language model that can write poems, that can come up with cooking recipes and can generate code, but if it's just tailored for one task in the industrial domain, answering questions on service reports, let's say, then probably you can live with much smaller models, which are a bit fine-tuned, as it is called, to the specific domain of your interest. So you provide some extra information which fine-tunes it to the domain, but then it can be much smaller and then consumes less energy and is more environmental friendly. And I think a lot of research is going into this direction, how to do that. Translates also in a less expensive bill for your electricity, which is also not bad.
No, that's super important. So you have a fantastic overview of artificial intelligence from the data and machine learning, the present stage of development. So looking a bit in the future, how would you see everything happening? Because at the moment we are in an interstice moment or a crossroad that everything can happen very fast. And of course there's some analysts speaking about doomed scenarios, but you guys are very positive, and I see from your answers that you are very practical as well. So how do you see the most significant impact on the industry when it comes to all the areas of AI development, especially industrial AI and industrial grade AI, but applied for the next 5 to 10 years? And how can we cope with that?
I think the development will go on quite quickly, and you can well extrapolate from now. I mean, now we have these large language models, we have vision models, we have first forms of multimodality. And I think step after step, we will cover all the other modalities which are relevant, like thinking in time series, thinking in terms of space and geometries. So it will be even more like our human brains. I mean, we also have all these modalities. We can talk, we can hear, we can see, can think about space and time, and all that step by step will be incorporated into these multi-model foundation models, and that will be a big step forward in terms of capabilities, not just adding one and one and one, but it's exponentially more powerful if you have all the combinations of reasoning and seeing and speaking and so on. So there's a lot of space for progress here. And then what I just touched upon, making all that more environment friendly and with less energy consumption, maybe much more specialized to certain tasks, like the human brain somehow works. I mean, we don't consume a megawatt of energy when we think, and still we come up with very good solutions in many cases. And there's lots of research to be done. And then, I mean, I'm always a friend of these seeing the AI as a kind of intelligence amplifier, not as a replacement of persons. So I think for the time to come, the most successful teams will be those that consist of humans and machines with different functionality, with different tasks. And we need to learn, and there's a lot to learn for us, how to take best advantage of the machines. What do I leave to them, and what I better do myself? And that sometimes we know already, but sometimes not. And these pairs or teams of human and AI, I think that will determine the future in the next year, how the industrial world will be working. I think it's not about replacing humans. We see how difficult it is to do the last bit, so the last percentage or milli-percentage of automation for autonomous driving. So if light conditions are bad, if your GPS fails, if other equipment fails, so we humans mostly have still a way to operate. And I mean, so the last little bit is always the most difficult part of AI. And so if we say, okay, don't optimize that, but better optimize the 50% that you can do and still have the human in the loop, then you're safe in terms of regulation and probably more progress. So this co-pilot assistant approach, I like a lot.
I love the vision, Adam. It's inspiring, and I hope that our audience can feel this sense of inspiration as well, pragmatism, because we need to take this. So I know that I'm on the end of the time. I have still 2 more questions. So one of the questions is, one of the things that Siemens is quite impressive, the work, is that you have collaboration with major global corporations. There's NVIDIA, there's Bosch, there's a lot of other companies that we're collaborating. So tell us a bit how these collaborations have been improving your capacity as well to improve your product and scale it, and as well create better business, because I think that's important as well in all the different things.
Today in the space of AI, there's no possibility to do it all alone. I mean, maybe 170 years ago, Siemens thought we can do everything ourselves, or even maybe some decades ago. But nowadays, you need partners, you need ecosystems to work with, and in the case of the large language model, it's well known that Siemens announced a partnership with Microsoft to be as fast as possible with products in that space, and so their collaboration is a good way. Now Siemens didn't limit itself just to going with Microsoft, but also with AWS, for example, NVIDIA and the industrial metaverse. There's a cooperation. So having good partnerships is absolutely key with the big players, but then on the other hand, also with the universities. So this should also be mentioned. We're closely working in many countries with the universities where the talent in the end comes from. And if you're cut off from that, you will never be state of the art. So lots of innovation is done in university collaboration with PhD students, and also the startups like you see here at this AI with Purpose Summit. So they are all over the place offering AI solutions themselves, which are not Siemens solutions, but which improve what we can offering. So these kind of ecosystems nowadays, it's key. It's key. Yeah.
And it's really, I believe, completely an ecosystem and network innovation. So last question, and it is about your personal work as a researcher and as an innovative personality. So for people listening to us, I think there's a lot of perplexity and a lot of questioning around the risks of AI, and you answered partly to that, but I would like more on the positive angle, and I love that you put it in a very inspiring way. But for instance, to keep going with the pace of innovation, and like you said, the pace of innovation on the academic, of research, on the business, and as well on the human emotional intelligence. So from your personal experience as a leader in a big corporation with hundreds of thousands of people, but as well working in a lot of different problems and challenges and putting practicalities, what is the part that drives you and the things that you would like to share with our audience around the world, but as well your partners in different parts? Because I think we need this inspiration on business and as well practical approach.
For me, with this all AI, it's still the question with which I started. So I still wonder, how does learning work, human learning and learning in machines? And that has somehow kept me curious all the time, all the years. And probably it's a good thing if you have maybe everybody has his own question, but if you have one question that you want to get answered in life, and then if you find a way somehow making this your profession, then you're quite lucky, and maybe you should look for that. So have a motivating question, and then see how through all the years, all the iterations, evolution steps of technology, how you can get that answered. And I'm still wondering what the final answer would be.
That's wonderful, and a great way to end. So it's been an honor. I personally am very inspired, and thank you so much. And I hope for everyone listening to us all over the world, please research Dr. Micahel May. We'll put all the information about him, about the work of Siemens, some links, and some of these case studies that we're talking. And well, I can only congratulate you for this excellent work and for this energy that is very positive.